My dear students, so in previous class we were discussing about the series solution for second order differential equation. What have we discussed? The nature of its solution: ordinary, regular, singular solutions, regular singular, irregular singular solutions. So the nature of the behavior of the solutions, that is, heavily depends upon the nature of or the behavior of the coefficients p of x and q of x. So now consider a problem. Find the power series solution of a second order linear differential equation y2 dash plus y equals 0. Find the power series solution of this second order differential equation y2 dash plus y equals 0. So, how to find out the power series solution? So you may consider the standard equation. It is y2 dash plus p of x y dash plus q of x y equals 0. So, when compared with the given equation, we have p of x equals 1 and p of x equals 0 and q of x equals 1. Means both of these p of x and q of x are analytic. They are analytic at x equals 0. Okay. Since it is analytic at x equals 0, we may assume that y equals sigma n ranges from 0 to infinity a n x power n with a solution. That's our assumption. So what is y dash here? It is y dash equals sigma n ranges from 1 to infinity n into a n x power n minus 1. Okay. Or before going to this one, for more convenience, what is y? Here y equals a0 plus a1x plus a2x square plus a3x cube plus etc. So what is y dash? Y dash equals, it is a1 plus 2a2x plus 3a3x square plus 4a4x cube plus etc. What is y2 dash? Y2 dash equals, it is 2a2 plus 6a3x plus 12a4x square plus etc. Okay. Now, the differential equation y2 dash plus y equals 0. If you substitute all of these values in this differential equation, so you will have y2 dash plus y equals 0. That means 2a2 plus 6a3x plus 12a4x square plus etc. Plus, what is y? It is a0 plus a1x plus a2x square plus etc. Okay. So compare. So equals 0 plus etc. plus equals 0. So comparing, what I get? 2a2 plus a0 equals 0. 2a2 plus a0 equals 0. That means, what is a2? a2 is in terms of a0, that is minus a0 by 2. Okay. When you compare the coefficient of x, so means 6a3 plus a1 equals 0. So from here, what is a3? a3 equals minus a1 by 6. Okay. Again, coefficient of x square, that is 12 a4 plus a2 equals 0. That means a2 equals it is a4 equals minus a2 by 12. But a2 is also expressed in terms of a0, that is minus a0 by 2. a2 is replaced by minus a0 by 2, so it is a4 is nothing but a4 by 24, and so on. If you compare the coefficient of x cube, what is the next one? 4a4x cube, then 5a5x power 4. 5, the next term is 5 a5 x power 4. Okay, so it is a3x cube, a4 x power 4 and a5 x power 5 means 5 a5 x power 4 y dash, and what about its y2 dash? Y2 dash means its y2 dash is 12 a5 x cube. So if you compare it, you have different values means a0, a1, a2, a3, a4. Some a2 is expressed in terms of a0 and a3 is expressed in terms of a1 and so on. What about if you compare the coefficient of x cube? What you get? Here this y2 dash means 20. So it is 20 a5 plus here a5, it is a3 x cube means a3 equals 0. That means a5 equals minus a3 by 20. But a3 is in terms of minus a1. So it is a1 by 6 into 20, that is 120 and so on. Okay, and so on. So, therefore what about y? Y equals a0 plus, that is a0 plus a1x. What is a1? So it is a1x plus a2x square. What is a2? In terms of a0, that is minus a0 by 2 into x square plus a3 x cube plus a3 x cube. What is a3? A3 is in terms of a1, that is minus a3 means minus a1 by 6 x cube plus a4 x power 4. What is a4? a0 by 24. So it is a0 by 24 into x power 4 plus a5. What is a5? Plus a1 in terms of a1 and so on. Plus it is as a1 by 120 into x power 5 plus etc. Okay. Yes. So that means what is y? So it is y equals, put a0 outside, so it is a0 into, what's the answer? It is 1 minus x square by 2, then plus a0 by 24, so it is plus x power 4 by 24 plus etc. Plus a1 into, collect the terms involving a1, so it is x minus x cube by 6 plus x power 5 by 120 plus etc. Okay. So that means y equals a0 into, come to the terms inside that bracket, 1 minus x square by 2 plus x cube by x square by 2 factorial plus x power 4 by 4 factorial. The next term is x power 6 by 6 factorial plus etc. What is that one? It is replaced as, means it is rearranged as 1 minus x square by 2, 2 means 2 factorial, plus x power 4 by 24, 24 means 4 factorial, plus etc. Plus a1 into, it is x minus x cube by 6 means 3 factorial, plus x power 5 by 120 means 5 factorial, plus etc. So, what about the term inside the brackets? Means that is y equals, that is rearranged as y equals a0 into the expression or the expansion in the first bracket, 1 minus x square by 2 factorial plus x power 4 by 4 factorial is nothing but it is cos x. So a0 cos x plus a1 x minus x cube by 3 factorial plus x power 5 by 5 factorial, that is sin x. So this is the solution of the given differential equation, second order differential equation in terms of power series. So the solution is y equals a0 into cos x plus a1 sin x. Means this y is expressed as a0 into y1x plus a1 into y2x. a0 y1x plus a0 y1x plus a1 y2x. What is y1? Here y1x is cos x And what is y to x? Y to x is sin x. Agreed? So here y1x and y2x. So one is not a constant multiple of other. Means here y1x by y2x. y1x by y2x is equal to some tan x, or sorry, as some cot x. So which is not a constant. Not a constant. Not a constant. Means now y1 and y2. Consider these two functions y1x and y2x, which are the power series form. So y1x is cos x and y2x is sin x. But their ratio is not a constant. Means one is not a constant multiple of other. Here y1 and y2 are not a constant multiple of other. Means they are linearly independent. That means this y1 and y2 are linearly independent. So precisely we can say that the solution y is nothing but the linear combination of two linearly independent solutions. The solution of given differential equation can be expressed as a linear combination of two linearly independent functions. Here here y1x and y2x are linearly independent. Why? Because one is not a constant multiple of other. Agreed. So this is the solution of the given differential equation y2 dash plus y equals 0. So it is expressed as y equals a0 cos x plus a1 sin x. Clear? So it is one is a constant multiple. One is not a constant multiple of other. So two functions are linearly independent. Here we see that two functions y1x and y2x are linearly independent. Why? Because one is not a constant multiple of other. Means their ratio is not a constant. Okay. Now you will consider another one. Consider the Legendre equation. If you consider the Legendre equation, what is the Legendre equation? So in previous class we already discussed the Legendre equation. It is of the form 1 minus x square y2 dash minus 2xy dash plus p into p plus 1 into y equals 0. Okay. So you may thus it is then solve this Legendre equation. The solution of this Legendre equation in terms of power series solution, or the solution of Legendre equation in terms of power series function. How? So the Legendre equation has a power series solution. Legendre equation, when you compare it with the second order differential equation, then we say that it is analytic at the point x equals 0. Okay, analytic at the point x equals 0. So the Legendre equation is, what is the Legendre equation? 1 minus x square into y2 dash minus 2xy dash plus p into p plus 1 into y equals 0. What is p? P is a constant. P is an arbitrary. P is nothing but a constant. So when you compare with the standard differential equation, p of x equals minus 2x by 1 minus x square and q of x equals p into p plus 1 divided by 1 minus x square. So as stated in previous class, it is both the p of x and q of x are analytic at x equals 0. Since they are analytic at x equals 0, since they are analytic at x equals 0, then we may assume that y equals sigma n ranges from 0 to infinity a n x power n be a series solution. So instead of this, suppose the functions are analytic at x equals 1, then you can only assume y equals sigma n ranges from 0 to infinity a n x minus 1 all power n be the power series solution. So that's the difference. If it is analytic at x equals x naught, what happens here? Then you can only assume, or as you can only assume that sigma n ranges from 0 to infinity a n x minus x naught all power n be the solution of the given differential equation. But here we know that which is analytic at the point x equals 0. So x naught is 0 here. So it is sigma n ranges from 0 to infinity a n x power n be the power series solution. Then as usual, What is y? Y is this one. What is y dash? Y dash equals sigma n ranges from 1 to infinity n a n x power n minus 1. Okay. What is y2 dash? Y2 dash equals sigma n ranges from 2 to infinity n into n minus 1 into n minus 1 into a n x power n minus 2. Okay. So from here, what is minus? There is a table 1 into y2 dash. If you open this bracket, the second term is minus x square y2 dash. So what is minus x square y2 dash here? Minus x square y2 dash means it is equal sigma n ranges from 2 to infinity n into n minus 1 into a n x power n. If you multiply together, it will become minus. So it is minus of n into n minus 1 into a n x power n. Again there is minus 2xy dash. What is minus 2xy dash? Equals minus 2 into sigma n ranges from 1 to infinity. It is n a n x power n. If you multiply x power n minus 1 with x, it will become x power n. Now supply all of these values here, and you getting the coefficient of x power n to 0. What do you get? First it is y2 dash. First term, if you open this bracket, first term is y2 dash. So it is, that means sigma n ranges from 2 to infinity n into n minus 1 into a n x power n minus 2. Okay, plus or minus x square y2 dash. What is x square y2 dash? Sigma minus sigma n ranges from 2 to infinity n into n minus 1 into a n x power x power n. Clear? Minus 2xy dash. Minus 2 into sigma n ranges from 1 to infinity n a n x power n. Plus p into p plus 1. P plus 1 into y. Y means sigma n ranges from 0 to infinity a n x power n equals 0. Okay. Now, comparing the coefficient of x power n here. Comparing coefficient of or equating coefficient of x power n. On right side it is 0. So, what are the coefficient of x power n here? The first is n into, minus s, equating the coefficients. So, what do you get? It is, this can be rearranged as n into n minus 1 n. So, one step is missing there. So consider the sigma n ranges from 2 to infinity n minus 1 a n x power n minus 2. So that can be rearranged as, if you replace n by n plus 2, what do you get? If you replace n by n plus 2, the first term is sigma n ranges from 0 to infinity. It is n is replaced by n plus 2. So it is n plus 2 into n is replaced by n plus 1, so the second term is n plus 1 into, so it is a n plus 2 x power n. Okay, minus, then here it is all the other terms, sigma n ranges from 2 to infinity n minus 1 a n x power n, and so on, all the other terms involving x power n. Okay, so if you compare the coefficient of x power n to 0, on right side it is 0. So what are the coefficients there? The first coefficient is n plus 2 into n plus 1 into a n plus 2. Okay. Next is minus of n into n minus 1 into a n. Next is minus 2 n a n. Next is p into plus p into p plus 1 into a n. So equals 0. Getting the coefficient of x power n. On right side it is 0, and on left side you can rearrange it as, rearrange it as n minus 1 a n x power n minus 2. Why? Because as it varies from 2 to infinity and the upper limit is infinity, then you can replace this n as n plus 2. So it does not alter the behavior of this two other terms in this series. So you can rearrange it as or replace n by n plus 2 2, so it is n become n plus 2, n minus 1 become n plus 1, so it is n plus 2, n plus 1, a n plus 2 into x power n. Then you can equate the coefficient of x power n. On right side it is 0 and left side it is n plus 2, n plus 1, a n plus 2 minus n minus 1 a n minus 2n a n plus p plus 1 a n equals 0. So that means n plus 2 into n plus 1 into a n plus 2 equals, it is a n into, what does it mean, sir? Here it is on to the right side, it is n into n, means n square minus n. Here it is minus 2n, plus 2n, and minus p into, or minus p square minus p. A n plus 2 equals a n into, if you bring all the terms except this a n plus 2 to the right side, and n plus 2 into n plus 1 a n plus 2 equals a n into n square minus n plus 2n minus p square minus p. That means a n plus 2 into the term on the left side becomes, or n plus 2 into n plus 1 equals, here n square minus p square. What is n square minus p square? It is n minus p, so it is n square minus p square, then minus n plus 2n, so it is n minus p, so plus n minus p into a. Okay, so that means a n plus 2 into a n plus 2 into n plus 1 into n plus 2 equals, come to the right side, it is n square minus p square and n minus p, which is common, n minus p is common, so it is n minus p into, what means, n plus p plus 1 into a. So this is a n plus 2. So a n plus 2 equals, what is a n plus 2? So that means a n plus 2 equals n minus p into n plus p plus 1 into a n all divided by n plus 1 into n plus 2. Put n equals 0. If n equals 0, what do you get? We can find out on left side it is a2 equals, we have a value. Put n equals 1, left side it is a3. Put n equals 2, left side it is a4, and so on. Then putting all of these values in, y equals a0 plus a1x plus a2x square plus etc. Then you have a series solution, and it is of the form some a1 into y1x plus a2 into y2x, then which is known as the legendary function. So the solution finally, if you rewrite it as, then finally you have y equals some a